parent functions for the different types. Remember last time when it was quadratics and cubics, we just did -2, -1, 0, 1, and 2, and looked at what those would be plugged in. So those work because remember how the domain was all real numbers for each of those? It was really easy to plug in everything, and we can square and cube anything. Square rooting and cube rooting is a little more difficult. We don't always get a nice answer. So we're going to choose a little more wisely things that go into our parent function. So when we build our parent function, honestly, I still want to use -2, -1, 0, 1, and 2, but I'm just limited by the function. So right now we're looking at the square root function. If you're working with real numbers, what numbers can you not calculate the square root of? Negatives, okay? So I don't want to use -2 and -1 because I literally can't use negatives, all right? So I'm not going to put those in my parent function. Instead, I'm going to start at 0, okay? What's the square root of 0? 0. And then I want to just kind of go up from there, but I want to pick things that are really convenient for me. So the next number normally I want to use is 1. Is 1 a really convenient number to plug into a square root function? Yes, because the square root of 1 is 1. Okay, so convenient. Normally the next number I want to use is 2. Is 2 super convenient for me to plug into a square root function? No, like I'm okay with writing rad 2, but that's not simple for me to like go and graph, right? So I want to skip to what next number would I want to go to? 4. And the square root of that would be 2. And then if I want one more point, what's the next number I'd go to? 9, and I get the square root of 3. Is everybody okay with how we're picking this parent function? So if it was difficult for you in the past to memorize, why all of a sudden is this one different? I want to use the same things, but I just literally can't. Like I can't plug in negatives, and if I try to plug in 1, 2, 3, those just really aren't very nice for working with square roots. So I tried to do that, but just picked the most convenient numbers near 0 that I could use, essentially. Okay, so when we graph that, it looks like this. So 0, 0, 1, 1, 4, 2, and 9, 3. And then sometimes people have a difficulty knowing which way to kind of draw the arrow. Which one is the endpoint like that you can't go past and plug in anything else in the function? Which of these x values? 0, right? This was like, I can't go past 0 to the negatives, but could I keep plugging in numbers bigger than 9? Yes, that makes this one an endpoint, but the arrow can come after 9, 3 because I could continue plugging some things in. So it's a very slow growing kind of curve, right? It almost looks flat, but it doesn't technically ever flatten out. Is that all right with everybody? Okay. All right, so let's say that we look at that same thing to build our cube root function, because its parent looks a little bit different too. But again, it's not because we want to change it up on you. It's because mathematically we're trying to pick the easiest numbers to plug in that are still really close to 0. So in our cube root, can we plug in negatives? Can you take the cube root of a negative number? Yes, okay. Cube root of -1 is -1. So I can plug in negatives. So normally I have kind of 0 in the middle, and I want the 2 closest negatives to that and the 2 closest positives to that to just kind of get what's going on. So the cube root of 0 is 0. That's convenient. The closest negative integer to that is -1. Can we take the cube root of -1? Is it nice and convenient? Yes. Okay, so we'll use -1. And the cube root of -1 is -1. All right, sorry guys. -1 is -1, so we pick that. Now, normally we pick -2. Is -2 a convenient number for you to take the cube root of? No, it's like I could write it, but I don't really know where to plot it. It's a little more difficult. What is the next convenient negative value that you would know the cube root of pretty simply? -8, okay? 8, because 2 times 2 times 2 gives us -8, and that makes its cube root -2. So again, we're not trying to be tricky and like switch up the parent functions on you. We're just trying to always pick things close to 0 and the most convenient things we could pick. And then the positive numbers would just be the positive versions of these. 1 is easy to cube root, I get 1, but 2, 3, 4, 5, 6, 7 are not simple numbers to cube root until I get to 8, and then the cube root of that is 2. So if you struggled before, the only reason I'm kind of going through this is you learned these parent functions in Algebra 2. Maybe you were really comfortable with them. But if you weren't really comfortable with them, hopefully now you see some rationale in why we picked these numbers, which will help you remember and build these a little bit faster when you have to graph a square root or a cube root. Okay? So if we plot these points, then we get something that looks like this. And again, it looks pretty flat. It is not technically flat. It does climb upward and downward just very, very slowly. Okay, like to get up to a height of 10, you'd have to go all the way out to 1,000 because the cube root of 1,000 would be 10. So like that's how long it takes it to grow that much. Okay? Is everybody okay with the parent functions? Yes. All right, so let's go through our characteristics pretty quickly because even though we want to remember them from Algebra 2, our focus is going to be on domain, range, intercepts, and doing the transformations of the graph, okay? So in the square root function, so we'll just let different people raise their hands and tell us each characteristic. So we're concentrating first on the square root function, right? Who can tell us HK from our equation? Josh? Good. And who can tell us the X-intercept from that equation? Paige? And the Y-intercept? Super tricky. Actually, there is one. See, our y-axis here, right? And it does hit right here at 0, 0. But this function can totally not have a y-intercept. We could write none. Most of the time, you always have a y-intercept. But this is a function that might not have one. What would cause that graph to not have a y-intercept? What kind of transformation would make it so that graph wouldn't have one? Good. Okay, if we moved it all to the right and there wasn't a reflection involved in there and we have our starting point somewhere to the right and it's still going that direction, then we don't see a y-intercept. Okay? So square root function is going to be a little tricky because it's possible to not have x-intercepts or y-intercepts because it has that stopping point. Okay. What about domain for our square root function? McKenna? Good. So it goes from 0 to positive infinity, okay, or that x has to be greater than or equal to 0. And if you're struggling with y, you can see visually that our graph literally stops at an x value of 0 and doesn't allow us to plug in anything smaller than 0. And also algebraically, when we made the parent function, we didn't plug in negatives because we couldn't get real number answers with that. That's why those numbers are not in our domain, okay? All right, what about our range for the square root parent function? Yeah, Aaron? Good. The same type of range here because it hasn't been shifted up or down. Our y values also have to be greater than or equal to 0. We're only getting 0 or positive answers when we do take the square root. Okay? All right, increasing interval and decreasing interval. If you're sitting on this curve and you're going across the graph from left to right, the whole time, what would you be doing? Increasing. Very slowly, right? It's not super steep, but you would be increasing. So the entire domain of the graph is an increasing interval. So look at your domain. Your domain is from 0 to infinity. That is also your increasing interval because the whole graph is increasing. Okay, so from 0 to infinity. And because the whole graph is increasing, then my decreasing interval is none. Okay. The rate of change, we're just going to write varies again, and axis of symmetry is not applicable to this function. Is this function 1-to-1? So it's a function, it passes the vertical line test. Does it also pass the horizontal line test? Yes, because it's not technically horizontal. If it's constantly climbing, it won't fail that test. So this is 1-to-1. What about minimum and maximum value? This square root function has which of them? A minimum value, right? It does keep climbing. We said that, but very slowly. So it has a minimum value and that y value is 0. And because it does keep climbing infinitely, it has no maximum value. And again, asymptotes here are not something that we use for these functions. Is everybody okay with like their understanding of the square root function and its basic idea of how it works before we go try to transform it later? All right, so let's talk about these same things for the cube root function. Okay, I'm just going to go backwards because I'm here. So again, asymptote's not applicable. Yeah, absolutely. So when you guys are doing this, remember, I'm not going to ask you all of these things here, but you do need to know them. It's something you're supposed to be familiar to from Algebra 2, okay? And the solutions to this will be posted. That's why I'm kind of going fast. I want us to focus on the transformations, the domain range, and the intercepts, okay? All right. Can I go to now? Is it okay? I'm trying to say. All right, so asymptotes you don't have to worry about here. What about minimum and maximum values? Yeah, or just none in this case. So I know it's kind of weird. None and not applicable mean different things. Like not applicable means there's like this isn't even something you would discuss with this function. Like this function, asymptotes don't live in the same world. Whereas none means like we talk about this with these kinds of functions, but this one happens to not reach that or not have one. So we generally write none, okay? And it's for both of them. Is everybody okay with why there's none for both the maximum and the minimum value? That this function climbs in both directions. Okay, axis of symmetry, again, is not something we talk about with this function, and rate of change is different everywhere in this function. All right, 1-to-1. Is this function 1-to-1? Yes. Okay, so it does cross the horizontal line test. It looks horizontal at some places, but that's just because it's growing very, 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 very slowly. Okay, so yes, it's 1-to-1. And then look at your cube root function. If you were on this function the whole time and you were moving across the graph from left to right, okay, what would you be doing the whole time you're moving across this graph? Increasing, sometimes steeply, sometimes not as steep, but the whole time you would be climbing upward. So our entire domain of this graph is increasing and has no decreasing interval. So no decreasing interval. The whole thing is increasing. And we haven't talked about domain yet, but what would the domain be of this graph? All real numbers. This is different than the square root, right? We can plug in everything. Not everything works out nicely, so we choose really nice things to plug in. But everything, which means our increasing interval is also everything because it's the entire domain. All right, and then what is the range of this graph? Again, all real numbers, right? So our square root was so limited because it had like that end point and everything just kind of spurted off there horizontally and vertically. But our cube root goes in both directions, kind of giving us like a cubic kind of, right? Since they are inverses, all real numbers. What about X and Y-intercept for the parent? 0, 0. And the H and K value for the parent? 0, 0. All right, are we okay with the parent functions and the review part from Algebra 2 about kind of the characteristics of what's happening? All right, so we're going to do the transformations. And while we do the transformations, though the whole chart is there, our focus, again, is going to be domain and range and X and Y intercepts, just the first portion of this chart right here, okay? All right, and remember, all the transformations are the same. So we're going to look at some complicated equations, but we're going to treat them the same as we would quadratics and cubics. The difference is how we're starting our parent function, okay? On the next page, if not, just be doing some of these equations.
I'm supposed to tell you guys to not go on your phones on the drill.
There you go. Don't go on your phones on the drill. Okay, we're going to focus on the square root first. And the first thing I want you guys to remember every time you approach an equation that we're working with in this class is that there is something more here than you did in Algebra 2. So slow down a little bit, because if you just jump right in with your H and your K, because of the B values, you're going to miss some of the stuff that's going on. So right away, see this negative 1/2 here? I need to rewrite this equation. And the -3 can stay. I want the negative half, but I want it separated from the X minus H group. Otherwise, I'll do the wrong shifting of my graph. And so then what is left in this set of parentheses that I've built here? So the first term should always be X. That's why you took out exactly what was in front of X to leave yourself with just X. And then this one is kind of a pretty complicated example. Depending on how good you are with number sense, you may or may not be comfortable with what else is left in the parentheses. Any ideas here? Okay, so if it was minus 1, if we multiply the half back in, what number would we have there? 1/2 times 1 would make a half. I know this one. Yeah, good. Okay, it's 4. And it's minus 4, right? So that when it multiplied, it would make a plus 2. So those of you that are like, oh, so you're just leaving us to figure it out? No. Okay, so either your number sense is at a place where you're good at figuring out that that's 4 and you can just like guess and check some things because you know what it should be and it's there. If not, think about what you did. There used to be a 2 there, and what you're doing is you are dividing out or factoring out a negative 1/2 from the 2. So you are literally taking 2 and dividing out negative 1/2, which is 2 times the reciprocal of negative 1/2, which is negative 4, sorry. Is that okay with everybody? So if you don't know how we're getting that number, like it doesn't just make sense to you what multiplied and whatever, that's totally okay. We all have different mathematical backgrounds and experiences, but there is a way for you to figure it out, okay? Take what was there, divide it by what you factored out, and see what should be left, okay? And so now I can see that my B value is negative 1/2, my H is actually positive 4, and my K is negative 3. Yes? Well, it does. So when I factored out the negative 1/2, it became X minus 4, and the X minus is part of the function, so the H value is positive 4. Is that okay? Does that answer your question? All right, so then remember what we do for each thing. We have a parent function table and then a transformed table. So my parent function table, I have to have this memorized, right? And I wanted numbers around 0 that I could quickly take the square root of because it's a square root function, and that's how we got these. And then our y values would literally just be the square root of those numbers. So you either just like flat out memorize that table, or you can quickly make it like we can here because we understand why it's being made the way it is. Our new table then is going to have to show all of our transformations. And I'm going to list them off to the side because you guys are supposed to be able to list the transformations as well. So vertically, let's start with that because the vertical stuff is a little simpler. What is our transformation vertically? What's the only thing that's going to go with the y? Good. The minus 3, which is shifting us down 3. So we have a shift down 3. So vertically with my y coordinates, I just want to subtract 3 from all of them. That's the only vertical thing because that is the only thing that is outside of the square root. Everything else is inside of the square root, which would affect x before square rooting it, which is like this column from our parent function. So everything else is a horizontal transformation. All right, so what is going to happen to x? There's actually 3 things that are happening there. Okay, can somebody tell me one of the things that's happening to x? In words, how would we say one of the things? Katrina? Okay, there's a shift right 4, and that's going to cause coordinates to have 4 added to them after they've already been adjusted other ways. Olivia? Good, but we're going to change that a little bit. Okay, so there is a horizontal reflection, and when she says horizontal reflection, horizontal means go left, right, or right, left, which means it goes over the y-axis even though it's changing x. Reflections are caused by multiplying by the negative. So the other part that she was saying, there is another horizontal thing because what have we not addressed? The half, right? So there's something else that's horizontal. And then is it a stretch or is it a compression? So remember what the 1/2 means in the equation in that spot versus how we measure it on the graph. So it means that x is kind of reaching different y values half as fast as it used to. So will it take x longer to get to that y value or shorter if it's going half as fast? Longer. It's like if you drove to school half as fast, it would actually take you longer to get here. So the equation has a half, indicating that x's are kind of moving half as fast as they normally do to reach y values. On the graph, we don't measure how fast they're going, we measure how many x's it takes. So if they're going half as fast, it takes more x's for us to reach that y value. So we're actually going to have a horizontal stretch, okay? And it's not going to be, we don't actually use 1/2. Instead, it's going to take, so if you drove to school half as fast as normal, it takes you longer. How much longer exactly? 2 times as long, the reciprocal of what you were using before. So we have a horizontal stretch by 2, and that's what's going to go there. Is everybody okay with why there's a stretch and not a compression? You have to think really hard about the horizontal meanings of these things. And does everybody understand why there was 3 horizontal things listed there? That multiplying by a negative is a reflection, multiplying by a number is a stretch or compression, and then adding and subtracting numbers is shifting it, okay? Because on your quizzes that you guys did, everybody did pretty well, but if you look back, the most common thing that was missed, but it wasn't worth like the majority of the points, was a lot of people for the negative that showed up in one of the equations said something like a stretch or a compression, but multiplying by a negative should only be thought of as a reflection. Is that okay? All right. So now we're going to go through and we are going to change all the things this way. And actually this arithmetic is going to work out a lot better than we might have thought it would with the half in there. We don't even actually have to multiply by a fraction. So that's actually very convenient. So I'm going to take this column of x values, and each x value is going to get transformed this way. So every x coordinate is going to get multiplied by -2 and have 4 added to it to do all of those horizontal transformations. So with 0, I'd end up with 4. With 1, I'll end up with 2. With 4, I'll end up with -4. And with 9, I'll end up with -14. Is it okay that I'm making that list kind of fast? I'm kind of assuming you guys know which numbers to plug in or doing the arithmetic. Did I do it wrong? Yeah, Brandon. Well, remember, I'm plugging 1 into this. So I'm doing -2 times 1, which is actually -2, and then adding it with 4. Is that okay? Okay. And now I'm going to go ahead and adjust all the, yeah, sorry, Olivia. We use the reciprocal because it's on the, it's 1/2 in the equation because it means one thing in the equation, but what we measure on the graph is actually the reciprocal of that, is the way it shows up on the graph, okay? Are those values okay with everybody? All right, and then the y values are all just going to get shifted down 3. So I'm just going to take all of the y values and subtract 3 and make that new list. And I'm going to plot these, and because it's a square root, I should kind of have that shape in my head that there's like this end point and something like this, right? And you don't want to lose track of which point is actually the end point. You want to make sure you draw your arrow in the right direction, otherwise it has totally different meaning. So which point do I want to keep track of as my end point? Which one is the one that like won't have the arrow? It's like the end of the graph. Aaron? Good. This point right here, and that makes sense because it matches with my H and K values like 0, 0 did, so it got transformed to that. So I'm going to plot 4, -3, and know that like that one's my end point, and then I'm going to plot the other points and try to like follow those. So 2, -2, -4, -1, and -14, 0 would be further than my graph goes. So something like this. Are we okay with that idea? All right, so let's fill in our HK, our domain, and our range, and we'll come back and solve for intercepts at the end, okay? So what is our HK value? We already talked about it, 4, -3. So we see it several times, right? It shows up in our equation, we're picking it out, and it should be the shifting in our transformations. So all those things should kind of match. What is our domain of this graph? Paige? Okay, So domain is X values. So you're focusing on, so what Paige gave me is basically the range, right? If we look at Y values, the smallest Y value we hit is -3. And does everybody understand the positive infinity part for the range, right? -3 is the minimum and the graph goes up. So for our range, I would agree that we're looking from -3 to infinity. But what about for our domain, looking horizontally at the X values that you're seeing? Olivia? Yeah. Sure. So X is less than or equal to 4. For those of you that like interval notation, that's no minimum, and 4 is the maximum. If you like the inequality notation, and for the second one, that would be that Y is above or equal to -3. Okay. Is everybody okay with the domain and the range? Right? And then if you really have to check yourself, remember you have your H's and your K's here. Your domain should revolve around the X's. If this is an endpoint, 4 is the endpoint for the X's. And then whether it's above that or below that, look at that on the graph. And then your Y values should go with your range, and the endpoint for that is at a value of -3. So your H and your K should help you with your domain and your range there. Okay? All right, and then we'll come back and get intercepts if everybody's good with what we have so far. Are we okay with that idea? And did we really pay attention to the B value? It's going to show up on your quiz, so I want to make sure that you guys are solid with how to use it. It didn't show up last time. Your Algebra 2 skills were strong. Phone? Yeah. Right on my computer. All right. So now cube root. Yeah, sorry, Paige.
So if you're given like a -2 as your value
Yeah.
for the table, it would be to shift 1 out.
Yeah, so let's say that you guys were given something to graph that looked like this, okay? Then I would first factor out my -2, right? And then when it looks like this, when I made my new transformed table, these are all horizontal because they're all inside the radical, so Y would just stay Y. And then horizontally, what would be happening to X is the reflection. There would now be a compression by a half because I'd be using the reciprocal, and I'd shift to the rate 3. Okay? Is that all right with everybody? Her question about the B value? Chance? Yes. So if this was a +2 here, then it would have just been like this, and I would have done this. Because remember, the negative is just a reflection, okay? So that's talked about separately than when we're talking about the stretching and compressing. So despite whether it's positive or negative, that's how we use the numerical part of the B value, okay? Any other questions about using that B value? Okay. All right, so our cube root doesn't have a B value, so I'm going to give you guys a couple minutes so that you guys can try and process and go through it yourself and do a little bit of work, just like you guys did on the quiz last week. So make sure you have down this new parent function because it's a cube root, and then we'll check together. Okay, yeah. Here's how I set up the charts. Is everybody okay with that? So what you should be checking is, did I use the right parent function? Like, am I paying attention? This is a cube root, and I understand what the parent function looks like. And then did I set up my transformations right? And then my question to you guys is, how do we say these in words? So what words do we write down for the different transformations we just filled into the chart? So somebody give me one of them. All right, so left 2. And so what is Paige looking at when she sees that? This part, right? That the X is being subtracted by 2. All right, somebody else give me another one. Yeah, Josh. Good. We're shifting up by 6. And do you guys see where he's looking at to say those words? Okay, how does it make sense? Our Y coordinates are getting 6 added to them. What else is happening vertically? Because there's another thing there. Griffin? Good. So there's a vertical stretch by that factor of 2. So there's the words, there's the chart. And so we're going to go ahead and graph this and see what it looks like. Remember, our graph should make sense. Okay, and does it look, sorry, yes, Paige.
When we say it's stretched and compressed, do you want us to indicate them for the total?
Yes. So that's different than Algebra 2 as well. They might have let you not say vertical because you were only dealing with one realm of it. You only studied it in one way. But now a horizontal stretch actually does the opposite of what a vertical stretch does. So we do need to know just which direction that it's happening in, okay? Does it make sense how it looks? So first, does it look like a cube root should look? Yes. Okay, and notice that the arrows go more left and right than they do up or down. Don't get confused with your cube root and your cubic, okay? So it looks how it's supposed to look. It just looks a little bit like larger vertically, like more spread out vertically, but that makes sense because you guys said that we have a vertical stretch, okay? All right, so what do we get as our HK values? -2, 6. And you should see those a couple different places, right? You should see them in your equation. You should see that 0, 0 was transformed to that in your table so that you're kind of checking what's happening. What's the domain for this function? All real numbers, right? And what about the range? Yeah, so your cubics and your cube roots are kind of nice in that respect, right? They don't have any stopping points or maximums or minimums, which means that we have the domain and range always of all real numbers. All right, the last thing that we want to do is we just want to make sure that you guys can calculate intercepts. That way we're leaving tomorrow fully for practicing all of the stuff. Does that make sense? So tomorrow you're just going to work on skills 4 and 5, or homeworks 4 and 5, and that way you're going to just practice square root and cube root graphing all period as preparation for your quiz on Thursday, okay? So if we look at the next page, I think has your intercepts, yeah. If you don't have the note guide, it's just the same equations you were using. We're just do the intercept work off to this side. So again, calculating a y-intercept for us is sometimes a little simpler because putting 0 in for x just means finishing a calculation on the right side. So I'm going to do those ones first. So I'm just replacing x with 0 first. And then remember how parentheses comes first in your order of operations, okay? Or if you learned it another way, sometimes they say the word as grouping symbols. The fact that everything is underneath a square root, like if you typed that into the calculator, your calculator would either have to extend the bar over everything or it would make you put parentheses around all of it to know it's all in the square root. So you need to do this calculation first, okay? What is that really the square root of? So in our case, 1/2 times 0 is 0, plus 2 is 2. And without a calculator, this is how we're going to leave it. We're not going to approximate the decimal on our own. So we're just going to literally leave it as it should cross the y-axis at this point. Okay? If you were feeling really horrible about it, you could approximate it to yourself. Like, you know, the square root of 2 is 1 point something-ish. If you do that 1 point something-ish minus 3, do you see a place on your graph that makes sense that that number, like, shouldn't be at like 10 or something, right? Okay, that kind of idea. So that's our y-intercept. If we had like the square root of like 16 in there, we would finish simplifying because we know the square root is 16 and we'd make the number simpler for ourselves. Okay? And so same thing with our cube root. If we put 0 in for x, the first thing you should calculate is what's underneath the cube root. So 0 plus 2 is 2. Is the cube root of 2 something that simplifies to like an integer, a nice whole value? No. Okay. And so then we're going to leave it like this. So our y-intercept for this cube root is this. It's super ugly, but we're just going to like let it be. We don't have to do any more work, so that's okay. All right. And again, if it was like the cube root of 8, if 8 was underneath the cube root, I would keep going because I know the cube root of 8 and it's 2, and then I would finish the calculation. But it's not like that, so that's why I'm stopping. Okay? Is everybody okay with the y-intercepts? Okay. So the x-intercepts require a little more work because you guys have to try to get x alone, and x is currently grouped with all of this other stuff. So like for our square root function, oops, I'm going to make my y equal to 0. The first steps of these are all really similar, whether it's a square root, a cube root, a squared, or a cube. Your first goal is to get this, whatever X is packaged in, get that piece alone, and then deal with getting rid of the stuff that's stopping you from being able to see X by itself. So the first thing I would do here is I'd add 3 to both sides. All right, now that I have like the square root package alone that contains X inside of it, what do I want to do so I have a chance at getting X by itself? Good, I want to square both sides. And you don't have to worry about plussing or minusing here, it's only when you square root, okay? So this would be 9 equals negative 1/2 X plus 2. And now we would finish solving from here. So I'm going to subtract 2 from each side. And I'm going to end up with 7 equals negative 1/2 X. And then I'm going to multiply both sides by negative 2 to cancel that negative 1/2. And I'm going to get that X is equal to negative 14. Now, you do have to be a little bit careful in these equations, because notice X would go underneath the radical, and what can we not have underneath the radical? A negative. Now, that doesn't mean X can't be negative. It means if I plug it back in, it better not make a negative underneath the radical. Is that okay? If I plug it back in, negative 14 gets multiplied by negative 1/2, and that becomes a positive value that adds with 2, so it's fine, okay? But just make sure you're not making like a negative underneath the radical. Or look back at your graph if you have the graph and make sure it's actually supposed to have X-intercepts. Okay? All right, and then the same idea with the cube root. We set y equal to 0. We're going to focus first on getting that cube root portion alone. So we would subtract 6 from both sides. And then we would divide by 2. I'm going to pause for a second to make sure everyone's okay with that. Are we okay with that idea? Okay, now I'm going to tell you guys right now, if I was back at that other problem, the square root one, and the square root had been equal to negative 3 instead of positive 3 right here before we squared both sides, I honestly would have stopped. If you're working with real numbers and you calculate a square root and it doesn't have a minus or anything in front of it, it's just a square root, are you ever going to get a negative answer? Square root of 4, 2, right? Unless they put a negative in front of it, I'm not going to get a negative. So if it's a square root, I would have stopped and been like, oh, this must not cross the x-axis. Is it okay that a cube root is equal to a negative? Yes, I can calculate cube roots that are equal to negatives. So just to pay attention while you're doing the algebra so that things make sense, okay? What am I going to do now at this point in order to finish solving? He hasn't talked to us yet. Jake, go ahead. Cube both sides. Okay, so at this point, I would have negative 27 equals x plus 2. Now I would subtract 2, and I would get that x is equal to negative 29. Okay, a little bit simpler than the quadratic and the cubic, even though you guys are more familiar with those ones. Those ones you had to square root and cube root, so your answers looked more complicated. Here you're undoing the radicals, so you get to square and cube and can usually do those calculations. Okay, is this all right with everybody? So if you have some time tonight, your goal would be to start homeworks 4 and 5. If you have the note guide in front of you, the problem sets are right below it. If not, the problem sets are posted on Canvas. The homework looks exactly like the cube root or the quadratic and the cubic homework. It's 8 problems of each. You're going to graph them using transformations. You're going to list the transformations, and you're going to have the tables and the H and K and the domain and range and the intercepts. Is that okay with everybody? All right. We are going to do this though tomorrow. Our whole